All right, class, settle in. Today we're going to talk about something you feel every single day, every year of your life, but that almost everybody gets completely wrong. We're talking about seasons, and we are about to bust a massive science myth. So let's do this.
Okay, let me paint you a picture. It's New Year's Day. Imagine you're in Ohio, all bundled up, there's a blizzard raging outside. But at that exact same moment, on the other side of the world, someone in Australia is at a beach party, slathering on sunscreen. Same planet, same sun, so what gives? How is that even possible?
Now, most people would say, well, duh, it's winter because we're farther from the sun. I mean, it just makes sense, right? Closer is hotter, farther is colder. Well, what if I told you that's totally, completely wrong? Get this, in January, when it's freezing in the northern hemisphere, Earth is actually 3 million miles closer to the sun. Yeah, mind-blowing, right? So if it's not the distance, what on earth is going on?
The answer, the real culprit, has nothing to do with how far away we are. It's all about geometry. It's all because our planet has a permanent lean. Now, to really get why a little lean changes everything, we need to quickly go over two key moves our planet is making, all the time.
First up, we've got rotation. Just picture a basketball spinning on a pro player's finger. The Earth does that little spin every 24 hours around an imaginary line we call an axis. It's our daily twirl, and it's what gives us day and night. Pretty straightforward.
But while it's doing that daily spin, Earth is also on a much, much bigger journey. We call that revolution. It's the 365-day trip Earth takes all the way around the sun. That's our year. And it's during this massive road trip that the whole secret to the seasons is revealed. And it all comes down to one little magic number. And here it is. This is the secret code, the magic number, 23.5 degrees. See, as Earth is cruising around the sun, it isn't sitting straight up and down. Nope, it's tilted permanently by 23.5 degrees. And, this is the most important part, that tilt never, ever changes.
And that's absolutely crucial. The axis isn't wobbling around like a confused spinning top. It's rock steady. It's always pointing at the exact same spot in space, at the North Star Polaris. So, because that tilt is locked in place, as Earth makes its journey, one half of the planet is always leaning towards the sun, and the other half is always leaning away.
Okay, so we've got a fixed tilt, a permanent lean. But how does that simple lean create something as dramatic as a blizzard or a heat wave? Well, it all comes down to the science of sunlight, and we can explain it with a super simple experiment you can do with a flashlight.
We'll call it the flashlight rule. Okay, imagine you shine a flashlight straight down at a table. You get a small, really bright, intense circle of light, right? All that energy is focused on one tiny spot. Now, just tilt the flashlight. What happens? The beam spreads out into a big, dim oval. It's the same amount of energy, but now it's diluted. You just figured out seasons.
That is exactly what's happening with the sun's rays. When our part of the planet is tilted towards the sun, we get those direct, concentrated, flashlight-pointed straight-down rays. That's summer. And when we're tilted away, the sunlight hits us at a low, shallow angle and spreads way out. That's what makes winter so cold.
So that 23.5-degree tilt is doing three huge things all at once. First, it changes the energy intensity, just like the flashlight. Second, it affects how much air the sunlight has to travel through. In winter, those low-angle rays have to slice through way more atmosphere, which kind of filters out some of the heat. And third, it determines how long our days are. Long, sunny days in the summer and short, dark ones in the winter.
So now, let's go on a full trip around the sun and see how this all plays out. As Earth makes its year-long journey, it hits 4 key checkpoints that officially mark the start of each season. And for those of us in the northern hemisphere, here they are. You've got the March equinox kicking off spring, the June solstice for summer, the September equinox for fall, and the December solstice for winter. Now, those two words are super important, solstice and equinox. Let's break them down.
A solstice is a day of extremes. It's the exact moment in our orbit when our half of the planet is tilted as far towards the sun as it can possibly get, or as far away as it can get. For us up north, the June solstice is our maximum lean-in. That's our longest day of the year, and the December solstice is our maximum lean-away, the shortest day.
And the other two checkpoints? Those are the equinoxes. And the name itself gives you a giant clue. Equinox is Latin for equal night. On these 2 days, the Earth's tilt isn't pointed towards or away from the sun. It's perfectly side-on,
So the sun's most direct rays are shining right on the equator, and pretty much everywhere on the planet gets a nice, balanced 12 hours of daylight and 12 hours of night.
Okay, let's bring it all home. We've talked about the tilt, direct versus indirect light, and our 4 seasonal checkpoints. Now it's time for the final slam dunk piece of evidence that proves the case for the tilt.
Just look at this. It's a perfect mirror effect. Because that tilt is fixed, the seasons in the 2 hemispheres are always the opposite. When the north is tilted toward the sun in June, having our summer, the south is automatically tilted away. It's winter down there. And when it's our winter in December, they're tilted in, enjoying their summer. It has to be that way.
And this takes us right back to our first puzzle. A blizzard in Ohio and a beach party in Australia happening on the very same day is the ultimate proof. It can't be about distance because we're all on the same planet. It is all about the direction of the lean. The tilt wins. The tilt is everything.
But that leads us with one last little brain bender. Think about this. During its summer, the North Pole gets 24 straight hours of sunlight. The sun never sets. So why isn't it the hottest place on Earth? Why doesn't all that ice just turn into a giant swimming pool?
And the answer, one last time, is the angle. Even with 24 hours of daylight, the sun's rays are hitting the poles at such a super low, shallow angle that all that energy gets spread out over a massive area. It proves the #1 rule of seasons. The angle of the light is way more important than how long you're in it. Angle always beats duration.
So, our entire world, our predictable, beautiful, life-giving seasons is all thanks to one stable 23.5-degree tilt. Kind of makes you think, though. Our whole planet is built on that specific number. What if it was different? What if someday it changed? That's a question to chew on. Thanks for tuning in.